Module 2 again is on transformations, and we've talked about two of them so far, translation and reflection. So a translation, remember, is a slide. It moves moves the figure somewhere on wherever we're moving it to, right? Reflections, we need a line of reflection, and it creates that mirror image. Okay, we focused on the different aspects that come along with that, but so far they haven't gotten any bigger or smaller, and they haven't changed their shape. So we're going to continue with this idea of transformations, and specifically our basic rigid motions or isometries, by dealing with a rotation, because a rotation is not going to change shape either. Things change, but it's not going to be their size or shape. So it says a rotation is a rotation turns a figure. Turns, spins, something like that, around a fixed point called its center of rotation. So for reflection, we need a line of reflection. For a rotation, we need a center of rotation. So for our examples, for our purposes that we're doing right now, the center of the rotation is going to be the origin. Remember, that's 0, 0, right? It doesn't have to be the center. That doesn't have to be the center always, but for what we're going to be doing, that's what we consider the center. And we're going to rotate in increments of 90 degrees. Okay, so again, later on in geometry, you're going to have different centers. You're going to be doing different amounts of degrees, but we're going to be doing them in increments of 90, and we'll talk about what those increments are. Okay? A couple things we need to be careful of is we have to pay attention to the direction of the rotation. All right, so if we start here and we're going this way around, okay, that is called clockwise. Not that you see many clocks like this anymore, but remember we have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if it goes around kind of to the right here, I guess, for me. Okay? But if it goes the other way, we say that this is counterclockwise. Okay, counterclockwise. Because we're kind of going backwards. We're going 12, 9, 6, 3, right? So it's really important that you pay attention to what direction we're going, because obviously if you change directions, you're changing your number of degrees. Now, speaking of degrees and our increments of 90, let's just say that we're starting in quadrant 1 here, right? Quadrant 1, maybe. Okay, so quadrant 1, 2, 3, and 4. Okay, so if we're starting in quadrant 1, so let's call this our starting point. If I'm going clockwise, down here would be 90 degrees. Over here would be 180 degrees. And if you keep going and you add another 90 to it, that's 270. All right, so these are the numbers we're going to be using. 90. I'm trying to write that clear, but 270. So 90, 180, and 270. Okay, but we're going to be moving in both directions. So let's look at some examples of that. Again, I want our focus to be on more than just rotating it, but what does it mean when we rotate it? Okay, so we're going to be careful about what direction we're moving in. Be careful with our number of degrees. We're also going to be careful that remember that we have A and A prime here. Okay, so this right here is our starting figure. It's our pre-image, or it's our original figure. And the reason I know it is because it doesn't have the little prime sign. We put the prime sign, right? Called our image, right? Our resulting figure. So if we're moving clockwise, okay? And clockwise, remember, is this direction. So if we're going from here to here, what rotation, how many degrees would it be from the origin to go from A to A prime? Well, that's 90 degrees. What if, though, we still are going from A to A prime, but this time we're moving counterclockwise, right? So I'm going from here all the way around to here. Okay, so I'm going from here, can't really do this, all the way around, oops, to here. That's bad. We're just gonna get rid of that, okay? So notice that this is, if I'm thinking this point matches up to this point, I'm coming around this way, right? So that's a pretty big angle. We can't just connect the points like I normally do and say, hey, that's 90, but there is a relationship here. Remember, if this goes 90 down here, 180 down here, it's 270 degrees. Okay? Honestly, if you go 360 minus 90, what do you get? 270, right? All right, so these would result in the exact same rotation, either 90 degrees clockwise or 270 degrees counterclockwise. So let's look at another example. Identify your original figure. That's the one without the prime. Okay, so if I'm moving clockwise, clockwise is this way. So I'm going from here all the way around to here. Well, count it, 90, 180, that would be 270 degrees clockwise. Now if we're going the other way, still from B to B prime, but now counterclockwise, that's this way, right? So notice one rotation, one quadrant would just be 90 degrees. Looking at this figure here. And again, I'm struggling with copying lines here, right? So squint a little bit, okay? If this here is my image, nope, my pre-image, what I'm starting with, and I know I'm starting with it because I don't have the little prime sign, and I want to move clockwise. Clockwise goes this way. So I'm going from here to here, okay? Since we're only dealing with 90-degree increments, this quadrant would be 190, this quadrant would be another 90, or 180. If, though, I want to go counterclockwise, that goes this way. Notice I always kind of take my pen and kind of go around in circles to get that feeling, right? Well, if I move it here, that's 90. If I hear another 90, that's 182. Not 182, 180 as well, or also, okay? So when it's 180 degrees, they're the same whether it's clockwise or counterclockwise. Just a couple more here. So number 4 here, identify this figure here is my image. This is my resulting figure. This is pre-image, image. So clockwise, that's this way. So if I'm going from here all the way around here, move it down here, that's 90. This is 180. That's again going to be 270 degrees. If I go counterclockwise from here to here, I'm just moving it 90 degrees. Okay. Again, notice when you add these together, they all add to 360. Because if you were to go all the way around the coordinate plane, around the origin, that's 360 degrees. Okay, E, here's my pre-image. If I'm going clockwise, boom, this way, 90, 180. And if that's 180, we know going the other way is also going to be 180. And finally, again, identifying my pre-image. If I'm moving clockwise, I'm going from this figure to this figure. That's a difference of 90 degrees. Oops, I've been keeping it blue this whole time, sorry. And if I go the other way, here to here, because that's counterclockwise, I'm going 90, 180, 270. There are, like I said, lots more degrees that you could rotate by. You're going to do that later. There are a lot of, any point can be our center of origin. You're going to do that later. We're going to focus on rotating, turning, spinning these figures around the origin 90, 180, 270 degrees, both clockwise and counterclockwise.